Hello, welcome to White Rose Maths Secondary Snacks. Today we're looking at Year 8's block on fractions, decimals and percentages. So here are the small steps from the block, and we'll be working towards this small step here. Find the original amount given the percentage is less than 100%, also known as reverse percentages. But we'll be visiting a few of the small steps along the way. This is what that step looks like on the scheme of learning. And we'll focus towards the end of the video on this exemplar question and throughout the video on these key questions. Is the original value greater or less than the given amount? And what percentage is the original amount? And how can we represent this using a bar model? So this is from an earlier step where students have been just getting familiar with how to use bar models for percentage questions. So percentage decrease with a multiplier. And they'll be looking at the bar model, the language, and linking that to the abstract operation of the multiplier. I prefer to think of these bar models, or to draw these bar models, as comparisons. So that would be where you have the original bar model over the new one. So you can see what's happened. It tells a bit more of a story, a before and an after, a then and a now. So in this case, you can see there's been a 0% decrease and that the multiplier is therefore 1. In the second example, the original is 100% and the new is 70%, so that's been a decrease of 30%. So we're getting students to just think about what's being represented and how that could look as language and as an abstract operation. And the final one there has been decreased by a lot more. That's a 70% decrease with a multiplier of 0.3. There's no context here. There's no drawing for the students. It's just familiarity. And the idea can be explored a little further in our premium resources, where students are asked to work out missing percentages. And in other questions, they are asked to draw bar models, and you can see there's a little logo there to encourage them that a bar model might be useful here. Have a look at those questions and have a think how you'd use them in the classroom. So let's move on to doing some calculations using bar models. In this case, it's a percentage increase question, again taken from the schemes a little bit earlier than our final small step. Dexter earns £30 a week for his paper round. His employer gives him a 30% pay rise. Which of the bar models shows this? Again, you'll see we're not asking students to draw here, we're just getting them to read and understand the representation. So you could strip those diagrams away and ask them to draw the most suitable bar model and see what they come up with, and then have that discussion within the class about whose is the best representation and why the other ones might not be suitable for this question. So it's a pay rise. Dexter's going to be earning more now, so that means it's the second bar model. Students can then use that to work out Dexter's new wage. Really important that they label the bar model. Always encourage your students to label as much as they can on the bar model, and that could be done using brackets. So in this case, his original wage is £30 and his new wage is what we're trying to find out. So a question mark goes across that whole bar. And it's at this point that students might start to go off and do their own calculations, whichever one they're most comfortable with. They might see that the 30% could be broken into 3 lots of 10%. 10% of 30 is £3. So the new wage is 30 plus 3 lots of £3, or £39. Some students might use that multiplier method, so they could see using the bar model from previous work that the multiplier is 1.3, and just do 1.3 times the 30 to get the £39. Either way, same answer, and nice that you can use the bar model just to kind of compare the original and the new and see, oh yeah, so that is 39, it's gone up from 30, which makes sense. What about finding the original amount then? Again, we'll be using bar models and key questions as prompts for the students as we go along. We're not going to actually answer this question. I'm just going to focus on Drymark, on the 20% off, now only £44. Why not pause the video and have a look at those key questions and think about when you would use those questions live modelling to a class. So Drymark, 20% off, now only £44. Let's do this question. Is the cost given more or less than the original amount? Would be one of our key questions. Let's see with a bar model. So the original amount was 100%. We've taken 20% off, so it looks like it's less than the original amount. What percentage remains after the reduction? Well, you can see there we've got a quite straightforward calculation of 100 take away 20. 80% remains. And now let's label the bar diagram, the bar model. £44 is the new cost, and we've been asked to find the original cost. So the question mark goes over the original bar. Use your bar model to estimate the original cost. All right, we're looking at it. I'd go with maybe about £50, a little bit more than 44. But at least I've got the idea that my answer should be a little bit more than that given value of £44. Students might see that 80% could be broken down into 4 lots of 20 and use that for their calculation. But again, there might be lots of different methods students might use. 44 divided by 4 gives us £11. So each of those equal parts is worth £11. So the original amount was £55. Could be labelled in the bar diagram on the above bar to show. One of the other misconceptions that comes up a lot with reverse percentages is just finding 20% of 44 and then adding it on. Why not ask students to use a bar model to show how that would not get you the correct answer? So the previous example for Drymark used 20%. It's not always going to be such a usable value, but it's nice to still use bar models to demonstrate the question, because all of those key questions are still valid. Is the cost more or less than the original amount? What percentage remains? And quite importantly, use your bar model to estimate the original cost, just to give students an idea of what their answer should look like. So we've got original is 100%, 4% has been taken off, and that remaining value is £44. We want to find the original, and we're left with 96. So at this point, again, students might go off and do their own preferred calculation. Nice idea would be to get students together to compare their methods and decide which one is most efficient for this question. So in summary, some bar model benefits for using reverse percentages are that it helps to visually build the question for students, gives them a good idea of proportion, which enables them therefore to have a sensible estimate and will support their estimate, therefore supporting their answer as well. Supports the abstract calculations, links methods, and as we saw, it also links language, and can be used to highlight misconceptions. So I hope that you'll be using bar models for your percentage questions from now on, and we'll love to see you soon for another White Rose Maths secondary snack. Thank you.